Hello everyone, I'm Nikhil Prakash from the Engineering Geology Group at ETS Zurich. With this very short pitch, I would like to draw your attention towards my poster which I present at the Swiss Geoscience Meet 2020. Landslides are a very common geohazard which are often triggered by earthquakes or extreme rainfall in mountainous regions. They affect a lot of people and are also a cause of many fatalities. It is important to create a catalog or inventory of these landslide events, but mapping them is a very difficult task and if done manually will consume a lot of time. These days, most of these landslide mapping efforts use Earth observation data to identify changes in the surface which are associated with mass movements. On the bottom right, you can see an inventory from Japan, which witnessed a lot of landslide events. They were triggered by a typhoon and an earthquake which occurred in quick succession. To exploit the wealth of Earth observation data, work has been done to create data-intensive machine learning methods. Traditional pixel-based and object-based methods have been adopted for landslide mapping with limited success. However, the recent advances in the deep learning methods have revolutionized the image interpretation tasks. When adopted for landslide mapping, they tend to outperform the traditional pixel-based and object-based methods. We have shown this in our recent publication, which you can access by scanning this QR code or going to this article. In the traditional machine learning workflow, we take an existing landslide inventory and split it into two non-overlapping regions, as shown here. We train a CNN model in the training area and use the testing area to test the performance of this model. If the performance of the CNN is good enough, we can then apply it to the surrounding regions and expand our existing inventory. Here is the result of applying our CNN model in a traditional approach. You can see the confusion matrix shows the true positive, and false negative detections. Here, the green polygons are the correct detections, the red polygons are the missed out landslides, and the blue polygons are over predictions. However, this approach cannot be used for a truly automatic mapping of landslides which are triggered by future events, as we do not yet have training inventory for them. To address this problem, we also developed a combined learning approach which is effective when mapping landslides for events which are not yet seen by our convolutional neural network. For more details, I invite you to my poster. We can even discuss further in the discussion channels. I will be available in both text and video channels. Thanks a lot.